so today we're finishing up with section 3.2 with the natural logs. Natural base e, we talked about e to the x and what its value was. We know the common log is base 10 and that the 10 is implied. In the natural log, it's log base e, but the most common way of notating it is natural log of x. This ln is natural log. It's ln, not in, it's ln for natural log of x. And it's saying it's a base of e. The properties all apply. Same properties. Base e of 1 is equal to 0. Base e to e is equal to 1. E to the x is equal to x. And if the natural logs are on both sides, then x has to equal y. Well, we're going to look at using our calculators to evaluate the functions. F of 2 equals the natural log of 2. You substitute, you put that into your calculator, and you'll get approximately 0.693. If I put f of 0.3 into my calculator, we're going to get approximately negative 1.204. If I put f of negative 1 into my calculator, I'm going to get either a domain error or a syntax error or some kind of error because I cannot take the log of a negative number. It's undefined. Properties to rewrite. We can use all the same properties that we've already learned. Okay, so this is the natural log of e to the negative 1, which if I wrote it using the word log, the base would be e to the negative 1. Idea, same principle. So this is equal to negative 1. E to the natural log. Again, same basis, so that's going to equal 5. 4. We know the log of any base of 1 is always equal to 0, so this is going to be 4 times 0, 0. 2. If they have the same base, we know that log base e of e has to be the exponent 1, so that's 2 times 1 equal 2. We find the domain and range exactly how we did with any log. It's the exact same way. The only thing that's different is the base. It could be base 3, 4, 10, e, doesn't matter. Our domain, it still has to be greater than 0, and my range will still be all real numbers. Here, my domain, x minus 3 has to be greater than 0, so x has to be greater than 0, 3. Adding 3 to both sides. Range, all real numbers. Exact same thing with any logs. Let's graph the natural log of x. Same process. Start with the domain. X greater than 0. Range, all real numbers. This defines my vertical asymptote at x equals 0. So now I have my inputs and my outputs. I still want x to equal 1, and I want x to equal my base. Well, e to the first is then approximately 2.72. Okay. So my output then will be natural log of 1. Natural log of 1, or log of any base of 1, going to be 0. Natural log of e, again, same basis, e, so that's going to equal 1. I plot these, 1, 0. 2.72 is about there, 1. Okay, so I'm putting it close to 3, a little over halfway of 2, and we're done. It's like another natural log graph. State the domain and range. It's how we always start. we want our domain, x plus 4 greater than 0, so x is greater than negative 4. Range, all real numbers. This defines my vertical asymptote, x equal negative 4. Now I'm going to go to my inputs and outputs. Again, I want my input of x plus 4 to equal 1, so x will equal negative 3. And I want my input of x plus 4 to equal the base, e. E to the first minus 4 is approximately negative 1.282. So when I look at putting this in, natural log negative 3 plus 4 plus 1. That's a natural log of 1 plus 1, which is 0, plus 1 equal 1. This one's a little trickier. What I'm saying is that my x plus 4 of my function right there, my x plus 4 of my function is equal to e. So I can go ahead and just say x plus 4 is e. Since x plus 4, I can just put it here, plus 1. Well, e to the first is 1, plus 1, 2. Let's plot our points. Negative 3, 1. Negative 1.28 right around there, and 2. My natural log graph. Okay, so there's word problems associated with natural logs. So students in a math class were given an exam and then retested monthly with an equivalent exam. The average scores for the class are given by the human memory model, 78 minus 17 log t plus 1, where t is greater than or equal to 0 and less than or equal to 12. T is the time in months. So what was the average score on the original exam? T is 0, so we want to find f of 0. 78 minus 17 log 0 plus 1. So I'm going to put this into my calculator, and you'll end up with 78. So the average score on the original exam when t was 0, 78. Now they're saying without any intervention or restudying, how much is retained by the human memory after 3 months? So I plug in f of 3. 78 minus 17 times log 3 plus 1. Substitute all that into my calculator, and the average score would be 67.76. So without any review or any intervention, the human memory loses its capacity. So we get from 78 average to a 60, almost a 68 average. All right, so now what about after 11 months? We're going to put this into our calculator, and we get approximately the average of 59.65. So as you can see, we lose memory. If we don't practice or use, we continue to lose what we learned in the beginning.